You know, we hear it all the time. Our devices are getting smarter. But have you ever really stopped to think about where that smart actually lives? Well, today, we're diving into Edge AI. It's the incredible tech that's basically putting a powerful brain right inside your pocket, and it is changing absolutely everything we thought we knew about speed, privacy, and what it means to be intelligent.
Seriously, think about it for a second. When you ask your phone for the weather, or, use one of those crazy filters on a photo, where is the actual thinking happening? The answer is at the very heart of a huge shift in how our technology works. And yeah, it might surprise you.
All right, so for the longest time, the answer to where does it think was pretty simple. Not on your phone. See, most of the AI we use every day has this fundamental issue. It has to do with distance. Let's call it AI's cloud conundrum.
That's right. The powerful intelligence that runs your favorite apps, it doesn't live in the device you're holding. It lives in these massive, sprawling data centers, sometimes in a completely different continent, packed with supercomputers. And your little device has to talk to them, constantly.
So picture this. Every single time you need an AI-powered answer, your phone has to wrap up your data, could be your voice, a photo, just a simple question, and it sends it on this long journey across the internet to one of those faraway servers.
And that's only half the story. That server then has to do its thing, come up with an answer, and then send it all the way back to your device. This whole round trip creates two massive problems. First, lag, that annoying delay. And second, huge privacy risks, because your personal data is just zipping across all these vulnerable networks.
Okay, so that's the problem. But what if there was a better way? What if? What if our devices could just do the thinking for themselves? Well, that is the incredible, revolutionary promise of Edge AI.
So what exactly is Edge AI? It's actually pretty simple. It's all about taking that AI brain and putting it directly inside the device. So instead of sending your data out to the cloud, your phone or your car or your smart home camera does all the heavy lifting, all the machine learning, right there on the edge of the network.
The first, most obvious win here is speed. You completely eliminate that trip to the cloud and back, so you get instantaneous, real-time responses. Now for us, that's convenient, but for something like a self-driving car or a robot in a factory, a millisecond of lag isn't just an annoyance. It could be the difference between braking safely and a total disaster. Next up, efficiency. Think about how crowded our internet networks are. Because all the data is processed right on the device, you're sending way less information over the internet. This frees up bandwidth for everyone and everything else, making our networks just work better.
And here's a real game changer. Edge AI doesn't need the internet to do its job. A smart security camera can still spot an intruder. A medical device can still analyze your vital signs, even if the Wi-Fi is completely down. That is a massive boost for reliability.
Now this is a big one. This probably hits closest to home for all of us. Privacy. With Edge AI, your sensitive, personal data, I'm talking about your private conversations, your health data, your location, it never has to leave your device. It's not being shipped off across the internet, which drastically cuts down the risk of it getting stolen or misused. And finally, it just makes our whole tech world stronger. It's kind of like, instead of having one giant power plant for an entire country, you give every neighborhood its own generator. By spreading out the intelligence, we're not relying on a few massive cloud servers. If one of them goes down, your local devices just keep on working. It's a much more resilient system. So you add all that up, and it becomes pretty clear, right? The Edge really does have the edge. It's faster, it's more efficient, it's more secure, and it's way more reliable. So if it's so great, why isn't everything already using it? Well, that is where our story gets really interesting. Welcome to what the experts call the TinyML challenge. The ML is for machine learning, of course, and the problem is exactly what it sounds like. How in the world do you take a giant AI brain, one that was built to run in a warehouse full of servers, and cram it onto the tiny, battery-powered chip inside your phone? Just look at the mismatch here. It's not even a fair fight. Cloud servers have insane computing power, practically unlimited memory, and they're plugged into the wall. An Edge device, it has a tiny fraction of that power, very little memory, and it has to sit power from a battery. It is a massive gap to bridge. So engineers are basically staring down three huge roadblocks. These big AI models demand a ton of computation. The models themselves are physically huge files, and they burn through energy like crazy, which is, a total disaster for battery life. And that energy problem? It's not just about your phone dying faster. It is a global issue. Just look at this number. By 2025, AI is on track to consume 100 terawatt-hours of electricity worldwide. That is the same amount of energy as the entire country of Sweden uses in a year. Making AI more efficient isn't just a tech problem. It's an environmental imperative. So, how on earth do you solve a problem this big? Well, engineers have developed this incredible toolkit of clever techniques, a set of secret weapons, really, for shrinking these giant AI brains down to size so they can finally fit on our devices. So let's look at a few of these tricks. First, you've got quantization. Imagine the AI thinks with super precise numbers, like 3.14159. Quantization just says, A, let's call it 3. It's less precise, but it takes up way less space. Then there's pruning. This is literally like pruning a rose bush. Engineers go in and snip away the weakest, least important connections in the AI's neural network, making it leaner and faster. Third is knowledge distillation. This one's cool. You have a huge, powerful teacher AI train a small, nimble student AI. The student learns to get the same results, just in a much more efficient way. And finally, neural architecture search, or NAS. This is like using an AI to design a better AI. It automatically tests thousands of different model designs to find the absolute most compact and efficient one possible.
So when you start using these amazing techniques, you're not just solving a technical problem. You are unlocking the future. So let's take a look at what actually happens when everything around us, from our cars to our coffee makers, gets smart.
And of course, we have to talk about the really big one right now, large language models, or LLMs. Imagine having a powerful AI co-pilot, like a ChatGPT, running directly on your laptop or in your car. One that works instantly, even if you're totally offline, and that never ever sends your private documents or conversations up to the cloud. That's the power of on-device LLMs.
And this chart really shows us where things stand today. The smaller AI models, yeah, they're pretty much ready to go on all our devices. But as you can see, those giant, ultra-powerful models are still stuck in the cloud for now. The big race, the real challenge, is using all those compression tricks we just talked about to get those bigger, smarter models ready to live right here, on the edge with us.
And the impact here goes so far beyond just smarter chatbots. This technology is going to unlock incredible applications everywhere. We're talking about medical wearables that can predict a health crisis before it happens, agile robots that can work safely alongside humans, and truly smart cities that can manage traffic and power in real time. So, this all brings us to a final, really exciting thought. Edge AI isn't just about making our phones a little bit faster. It's about creating a world where intelligence can be embedded in almost anything you can imagine. And so, the real question, the one I want to leave you with, is this. When every single object around you is smart, what will you build?